Make sure you understand the problem. We want to know how long will it take $2,000 to grow to $3,000. So $3,000 is actually the amount we want to get to, given that we have a principal of $2,000 now, and that's 1 plus, the rate of interest is given to be 7%, so that's 7/100. We are compounding semi-annually, so the number of times compounding per year is 2, and this is raised to a power of then, remember once again, n is 2, and t is what we're looking for. How long will it take this to grow to this? And notice that t is our only unknown. I'm going to first divide both sides by 2,000. Now 3,000 divided by 2,000 is the same as 3 over 2, or 1 5/10. And then that's equal to, I'll go ahead and simplify this just so it'll look a lot nicer. 1 plus 7/100 divided by 2 is actually 1.035. Now let me write that a little bit lower so I can show you the 2t. Okay, once again, 3,000 divided by 2,000, that's 1 5/10. And then this simplified is 1.035. I'm still raised to a power of 2t. What we will now do is we'll take the logarithm of both sides so that we can bring down this exponent containing our variable. So I'll just take the natural log of the left side, and I'll take the natural log of the right side, 1.035 raised to a power of 2t. Now, what was the whole reason of taking the natural log? So that I can bring this exponent down. So this is natural log 1 5/10 is equal to 2t natural log 1.035. Concentrate on this variable. This is all multiplication, and we want to solve for t, so we will simply divide both sides of this equation by the coefficient of t. In other words, everything but t. So I'll divide by 2, and I'll divide by natural log of 1 35/1000. If I do that on the right side, I must do the same thing on the left side. 2 natural log 1 35,000. Notice everything divides out. The right side is t. Let's go ahead and use our calculator and approximate this. And if you do, it's approximately 5 89/100. Remember, we're told to round to the nearest whole, so to the nearest whole year, it's approximately 6 years. That's how long it takes 2,000 to grow to 3,000 given these other constraints.